Hi, this will be a demo of a duplex deadlock in HttpClient in .NET 8 and how to fix it. So first we're going to start our server. It's Kestrel. It is being goofy in that it will return the response body before it reads the request body, but that really has nothing to do with this issue. You can actually point the client to any site that supports HTTP2 and you will get the same issue where it just won't send the headers on the request. So we've got our client started. We have Wireshark configured. If you go into Preferences, Protocols, scroll down to TLS, click Edit, and make sure you've got localhost port 5050, HTTP, and then navigate to the dummy local key. The configuration of HTTP client in this test application restricts it to use a cipher that does not use Diffie-Hellman key exchange so that it can decrypt the packets. Okay, so we'll start the recording and we will go to our project here. We'll go to our client and we're going to run one of our commands. We've got various test modes here, so let's do the complete deadlock with one request. And what it's going to do is it will send the first request, but it cannot send a subsequent request. And the reason for that is on the first request, it's establishing the connection, and there is enough data to be sent and the connection being established that it will trigger a case that will force a flush. But the second request will fail to ever send. And the place that it is parked at is over here, I believe in send async. Right there, it's stuck on that line. It'll never get to this line. Okay, so let's cancel that one. Then we can run the complete deadlock with many requests. That one is just toast, it looks like. Yeah, never sends any of them. If we go back to Wireshark, what we'll see in the beginning here is we got that first request. It did send headers. It got a response coming from 5050. It got all the data. I'm sorry, it sent data to the server, but then the subsequent request or connection in that next deadlock, it just does settings and window update, and it never actually sends the headers for the 10 requests that are trying to send. So if we cancel that, and then let's stop this and clear it so we can see what's happening again. Now we'll run many headers. Many headers I think will also deadlock. Yeah, it just does settings and window update, so let's cancel that. The point of sending many headers is to give enough data that it will force a flush, but it doesn't do it with one request always. If we do a partial deadlock with many requests, what's happening here is the subsequent requests are essentially causing a flush of the prior requests because they're all sending headers, and we're sending a batch of 10 requests in parallel every second, so it completes in about 10 seconds. This is a reason why if you run certain tests on this, you'll think there's no problem. What are you talking about? If we also then run the duplex test, so we've got the half duplex requests, and what that means is we're going to be sending a request where either there's no post body or the entire post body is available at the time of the request, which is the default and only exposed operation mode supported by HttpClient. If you want to use duplex, you have to implement your own content class, which is what we've done. We actually borrowed it from the HttpClient source code. So if we run these half duplex requests, what we'll see is it'll hang. All right, yep, it's hung. And then every 5 seconds, we send a half duplex request. And that half duplex request then causes all the buffered requests or buffered frames in front of it to be sent. So what we'll see is that this will actually take a full 50 seconds to complete. You can tell it's not 10 seconds, so I'll move on. Now, what does the fix look like? The fix may also apply to HTTP3 because it's got the same lines. But essentially in send async, the very first thing it's going to do is send the headers, and it's going to pass this must flush parameter. So if you're asking for an expect continue, it's going to flush. If it's an extended connect request, it's going to flush, but this or duplex is not here. If you add this or duplex, then when it sees that it's a duplex request, it will flush the headers, which makes perfect sense. If we go to that send async or headers async function, you see in the bottom line here, it's going to return true if it's end of stream. So that's either a post where the entire content body is available on send, or it's a get request or anything that doesn't have a body. And then must flush is that parameter that we're passing in. It's kind of odd here that there's not also like, I don't know if it's end headers. It's kind of odd that it's not that. I can't think of a case why that wouldn't be there. I also can't think of a case why it wouldn't just be this, because the nominal case that's happening 99.9% of the time when it has an end stream when it's sending the headers is that it's doing exactly this. It's only, as far as I can tell, duplex requests that don't get this true. So that is another way to fix it. But the narrower fix is to just go back to where this is called. And move this line was down. This line was down here. So we just move this up, and then we add in the or duplex here. So let's build this. And even though we get some errors, it doesn't matter. It's complaining about various platforms that I'm not building for. So this was last built at 1028, so we need to see a timestamp of 135. Okay, we got our 135, and if we check the project file, you will see, whoops, there is the optimized faults so that we can set breakpoints in there. Now we'll come over here. We don't need to stop the server because we're only changing the client, and we will uncomment this and this, and then we will check our HTTP2. Okay, so we have a breakpoint set here. I'm going to run the partial deadlock. And since we're not running under a debugger, it's going to run fast. So let's run it under the debugger. And we should hit that breakpoint. Okay, so now we're at the breakpoint. We see duplex is true. So the calculated value of must flush is going to be true. And of course we're doing 10 in parallel, so it's going to want to step through all of them. All right, now we can see must flush is true. So let's detach and let it run. Of course it killed it, so we will just run it this way. This is the request that took 50 seconds, or the mode that took 50 seconds before. Now it's only going to take 10 seconds because of this fix. And that's because of our sleep between each of the requests. And of course, all the other cases like one request deadlock, that should also finish immediately. Well, in 10 seconds. Send one at a time for a second delay between each. Yep. And that's it. So hopefully anybody else using duplex on HTTP2 with HttpClient in .NET 8 can use this fix, or we can get it merged in. Thanks. Bye.